So now that we've talked about one-dimensional arrays, let's talk a little bit about higher dimensional arrays. So let's just start with this declaration of an integer array which is two dimensions, it's 3 by 3, and it's initialized to have these values. And so before, when we, if this was a 1D array like this, we said that 2D was really secretly sort of like a constant pointer, and then there were a bunch of contiguous memory slots allocated. So now I think I am 99% sure that the rule now is that any particular, if I do like, what if I just consider 2D 0. So if I think of this as like an array of arrays, this is the first array. So in this case, this would be 1, 2, 3. And those are contiguously allocated. But it might be that the distance between 2D and 2D1, which refers to the second array here in the array of arrays, is not packed solidly. You know what I mean? Like there might be some padding between the end of this array and this array. And let's actually check this so we don't, just have to wonder for the rest of our lives. So this is the address of the first array, and now let's do the same thing for this guy. And let's see, so it's 3 things, and each one of these is 4 bytes. So it should be 12. So we'll check to see if if the second one is 12 more than this first one. Be an interesting experiment. And it's probably going to yell at me for various reasons. What is it? On line 18, invalid operands to binary, blah blah blah. Oh, it's because it's already an address, so I don't need that. And also I forgot my commas, which might be one thing that's making it angry too. And now it's still mad. And it's talking about this function foo, but let's just forget this stuff, and I'll come back to that in a minute. And is it happy now? Yes. And so let's see what it says. So, alright, so it's C, and C is 10 is A, 11 is B, 12 is C. So it is packed solidly in this case, but I don't think there's any guarantee. We might, go on and check this would be the address at which this very last array starts, and let's see if that's 12 more than the previous one. But you might have to do the hex arithmetic for me because it sounds really confusing. So why is it only still printing out 2 things? I commanded it to print out 3 things. There it goes. So can BC do, I'm just going to pray that this works. What if I take this guy and subtract this guy? So please work, BC, don't fail me now. And it doesn't know, but God. There's this great calculator that definitely does know. And if I wasn't just an idiot, I would just do this myself. I'm sorry. I do have a PhD in mathematics, but math is not really my thing. So the difference between those is 12. Yeah, so it's packed tight, but it doesn't have to be. And so now we realize what kind of a creature this is. Like if we had sort of a God's eye view of memory, this would just be what is this, 9 times 4 bytes, and so it's 36 bytes, and in the first 4 bytes there's the binary number corresponding to 1, and so forth. So that's what it looks like. Now if you want to refer to these elements, you do it like this. So this was when I had the one subscript here, it was an address type. So to get the good stuff, I use just 2 indices like that. And if I can get rid of speed crunch here, I'll show you. So that should print out, sorry, I have to recompile. And so that'll print out 9 because 9 is in, remember, it goes 0, 1, 2. So this is the second subarray, which is really, we would think of it as the third one. And the second element, so 0, 1, 2 is 9. If you wanted to print out all of these things, this is something that you frequently need to do, so let's do it. So we need two counter variables, one to go sort of across and one to go down. And to maybe make a little bit more clear what I mean by that, I'm thinking of this thing as being a square and like a matrix like this. So I'm thinking of it as having rows and columns. So it has 3 rows and 3 columns, which of course go 0, 1, 2, not 1, 2, 3. So I'm going to use these variables to look through. So I'll have an outer for loop, and I'll think of I as being the row, which it usually is in math, and it's going to be less than 3 because there are 3 subarrays here. And of course, just like the case was with 1D arrays, the stupid C programming language has absolutely no idea how long or what the dimensions of that thing are after you define it. So it's something that you have to keep track of yourself. Now I'll use the second counter variable j to go across the columns. So initially I will be 0. That means I'll be talking about the first row. And then j will do its thing. So j goes from 0 to 3, j++, and so we can print out the values here. So we'll do print f. Printing integers is so freaking hard, and C, it's strange. Something you have to do so often. And so here, how do you get the ith row and the jth column? Well, it's just ij, very easy. And so the picture looks nice. We'll do a nice line break here. And so that should print out a square that looks a lot like this thing. And let's get rid of it so the compiler doesn't freak out. Why can't the compiler ever just be cool? And so it's printing out 9 from that line. But you can see that it's printing out the thing just the way we thought of it. Going I is doing row by row, j is doing column by column. And if we wanted to, we could be manipulating this thing somehow. This is called a nested repeat loop. And you need a nested repeat loop to look through a two-dimensional array. It's something you need to do all the time. Like if you have a spreadsheet, then that's a two-dimensional array. A JPEG is a two-dimensional array. Many things are two-dimensional arrays. They come up all the time. Or a chessboard is a two-dimensional array, Scrabble board, etc. if you're programming some kind of game or something. And great. So that's about all there is to say about this thing, except for maybe the syntax of passing this thing to a function. So what if you want to pass a two-dimensional array to a function? So it turns out you have to do it like this, and there's some various plausible things that you might try, right? One thing that you might try is to do it as a double pointer. And sorry, okay, so I guess I need to. I'm going to take this, and I'm going to start making a print function because that might come in handy later. And so let's not waste that. Later I might want to print out some arrays, and of course I'm going to need some inputs and stuff. But so I don't get syntax vomit, I'm going to comment that out for the moment. And so let's pass this thing into the function foo. So what if I give foo 2d? It gives me a warning. Oh, right. So this is the whole point: is that it doesn't like it when you do it that way. Seems like it should work because it's it's a pointer to a pointer sort of situation. If I go ahead and run this program, though, referencing this element, it'll give me a segmentation fault. Right, and so something goes wrong there. Another thing that seems like it might work is if you do an array of int pointers. So this tells it that it's an array of int pointers, kind of the same way that this is an array of char stars. Seems like that might plausibly work, but again, you get a warning about that, and again, it blows the hell up when you try to run it. So what do? You do it like this, all right? So here's the third plausible thing. Maybe you should just say, "Shut up, tell me what to do," and that blows up. But it doesn't blow up if you tell it what the dimension is. You only have to. You can tell it both dimensions, but it's enough just to tell it the last dimension. So the last dimension is 3. It's happy. So that's how you pass a 2D array like that to a function. Very important, basic thing. So now I'm kind of done with this guy. So let's put that out of our minds, and maybe I think I'm going to stop the video and so those are sort of like full-fledged 2D arrays, and then I'll make another video on these things, jagged arrays, and then finally dynamic arrays. So I'll do that in 3 different shoots.